let's see how we're going to secure with Fortigate the Kubernetes environments. We're using AKS deployment, and we provide in the FortiStacks project on GitHub a way to deploy exactly the demo you're going to use here and see, just for the sake of not making a 1-hour video for showing you how to do stuff. I also provide a Docker image with all the tools, Azure CLI and AKS and Kubernetes CLI, all set up with capability to use SSL inspection. The curious people can get up to that. So basically, once you get your tools in order, the only thing you need to create to log into your Azure account and to deploy the secure AKS account. That will look like this. I'll have internet, load balancer, a VNet with a Fortigate, a FortiWeb, another subnet appearing to the AKS private managed VNet. It's very important to protect your API and to protect your environments here, and the Fortigate will be on the way out on the egress user-defined routes. All those are based on Azure recommendations to get to that. Then we VPN to the environments, and this is what we get here. I already VPN to the environment. So we have it deployed. You can see that I have a Kubernetes dashboard with something already deployed. Here we are in the Azure portal where we see the diagram view of the VNet. The VNet that is for the FortiWeb. The VNet for AKS is very simple. Let's say it's one subnet, and the AKS API endpoints in it, which is a very important part. This AKS is using private API features, and it's available also in the FortiStacks project, so you can see how it's done. Let's go do it now. As you remember, I have a single script here that deploys the full Fortinet infra, the different VNets, but more importantly, the AKS is deployed like this with private clustering, a network plug in Azure, so we have the CNI. I choose which subnet, a network policy, and a non-outbound type of user-defined routing, which allows me to have every traffic going out of the AKS cluster to go through the Fortigate. And if I check my Fortigate, I have my policies. And we can see the different traffic. And also, we can actually see the application name. So we can discriminate which traffic. So this is traffic going back for monitoring to Azure. As you can see, we can detect if a Docker command has been done. So this means a node did a Docker pull image. Can of course get the node because I deployed something. I get a manifest, the Docker, the blob, etc. So I can create very, very precise policy on the behavior of the cluster. Let's go back to the cluster again. So I have the dashboard and I enabled SSL inspection on this traffic, on this egress traffic. This allows me to have antivirus checks and can also enable DLP, data protection. Let me show you. Let me clear that. And then even in the stuff. You can see that I can access because I create a VPN back from where I am to the Fortigate, which has then access to the Kubernetes. So it allows me to use kube control thing. We're going back to this view later on, but show you that we have a bunch of service running and a load balancer pod, which I can access back because on the Fortigate I created a virtual IP and port forwarding. So if you check, this is the same IP as my Fortigate. If I go to this specific port, all the traffic is redirected to the internal load balancer of Azure. It's a feature of Azure. It's available on any public cloud. You can have an internal load balancer for your service, and I can deploy a very simple demo for that, just to show the traffic. And here you see I have my other policies. I have an ingress and an egress traffic. Egress goes there, and on the egress I enabled antivirus and deep inspection. This means you need to have the CA for this Fortigate deployed, but I did it with the node template, meaning, and you have the scripts, meaning even if you change the number of nodes in your Kubernetes cluster, they will have the Fortigate CA setup. And what this allows is I provide you in the environment a very specific image with the ACAR malware, and you can see I have an error image pool. So and it doesn't start. What's going on? Let's go back to the. Let's go to the. Where is my? Let's go to the dashboard. Again, the dashboard is internal. As you can see, it's an internal address. You can't access the dashboards from the outside. It's a very risky business to do this. Don't. And you can see that my ACAR has been blocked. And you have a little explanation. File guaranteed. Node. It's infected with the virus. So ACAR is not a real virus. It's a way for exercising the antivirus software. Let's go to the threat sections of my Fortigate. You will see that it's been deployed. So we have also another, and I create another project, which is a controller for Fortigate. And as you can see here, I also create custom resources, which means I can have multiple load balancers running on one Fortigate, and I can have multiple Fortigates running for the sake of the applications running. Meaning I can place my Fortigate and do my security checks as the load balancer, while the controller makes sure it behaves as Kubernetes expects from a load balancer. And we can simply enable this very, very, very integrated. You take, and I took the examples from Azure with Vote. I have Vote 2 because it's just the name, but it's just the Azure Vote, which you add a simple annotation, same way as you do for internal load balancer. And by the way, I enable the internal load balancer because otherwise you have controller to controller fights. And I set up the load balancer this way. So you mean you can decide which ports the load balancer will run on the FortiGate. And you can also have multiple FortiGates for that. So you can really place your applications on different pieces and parts, and then it will be able to do the load balancing. As you can see in my FortiGate, I don't have a load balancer set up yet, or policy, or health checks, or anything. Okay, let's go and deploy this app. You will see in this little checks, it's kubectl get pod, and you see that I have a custom resources and BFGT, all managed by the controller. And that my service has been started. If you check, I have my 0.22. 0.22 is Azure VOD 2 front, and same for 37. As you can see, I can access this. Meaning, I should be able to access using the external IP of the FortiGate and the port 890. Let's verify. I can now access this, and I can benchmark on it, and the Kubernetes will auto-scale up and down. It takes a bit of time, so going to, it's available in the demo. You even have the command line. Let's go into monitor the FortiGate. And I can simply increase the number of replicas. So you see Kubernetes is deploying. And because I have a health check, so I have a way, and it's specific. That's why you see the status up and down, and this status is reported here. It goes fast. You have to be careful. But this status here is actually the same as this view. Meaning that if you see the number of service and it's up, it means the health check on the FortiGate has been set up, and it's reporting the server. You can see someone, not me, but the controller, created a virtual server on the FortiGate and did the up and down. And if I wait, you will see the number of servers going down because I enable autoscale. And the health check has been set up here. In the upcoming version of the controller, you will be able to control this with the custom resources. So meaning you will be able to change the behavior of your load balancer and the health checks. So you can create precise health checks, doing a get on HTTP and getting the response, etc. On the FortiGate itself, so that the load balancer works well and directly there. And you get all the features. But you can also enable this load balancer to be HTTPS. Here I only, for the sake of the demo, did HTTP, but you can change your firewall VIP and load balancer. People who knows Fortinet is very common to deal with the FortiGate and the HTTPS. Another aspect of what Fortigate can do for you is that we have a fabric connector. And as you see, my Kubernetes connector is already set up and connected. And have a look. But the most important part is that you can create objects in the Fortigate that are populated with labels and nodes. So no matter how many or if those change by the Kubernetes environments, my firewall and my security policy will remain. And you can even provision that in advance so that your policy and your security guys knows this is this Kubernetes name and app, but I don't need to know in advance all the IPs and the traffic. The Fortigate will auto-adapt to that, and then you can create policies based on that. Matter of fact, if I go to the policy, I can create a new policy for this specific one, and this specific one is here. It's this one for which I created, instead of creating a load balancer on the Fortigate, I created a VIP manually, a virtual IP that does port forwarding to this internal IP, which is the internal load balancer IP that I get here. Because I set up this deployment with internal load balancer of Azure, meaning I can have my service here and I can create the different pieces and parts from there. I will have to do a load balancer, a virtual servers and load balancers if I wanted to have the rest. And you can see the health checks that has been created initially by the controller. So that allows us to have very precise policy based on objects in the Kubernetes environments and not on and the corresponding IPs. Another thing I wanted to show you is that every of those pods, because I enable CNI, every of those pods have an IP on the subnet, and same as the nodes. Meaning in my checks and traffic checks, I can relate the traffic to the service. So I know that this IP is, let's go check. Big. So here it is. 1040.036 is the Calico node. It's the Calico node going to dctrafficmanager.net to send information to an Azure application. Or I can get this. It's probably a node. Yes, it's a node. Doing a Docker pull and push. Another things we can do is, because we have those different applications, we can also create a policy specific to Docker pull and push and traffic, meaning you can forbid one or the other, or quarantine, as you saw, because we enable SSL inspection, we already be able to detect malware in there. In the same vein of detecting malware and other things, we are able to detect the DLPs, keys, tokens, etc., that may move around in a network in a wrong directions. Then we can really create for the infra and the applications together the right protections for those environments and applications, which, based on policies and dynamic objects, will not slow down the developers and will get all the benefits of the all good security features and postures. And hope you enjoyed it, and looking forward for more infos on those on Fortinet and Kubernetes integration. As you saw in the demo, we take back here the architecture, and we were able to put a firewall to protect the API and to protect the environments, and also to protect the egress traffic, to find malware, to find other things, with a very granular capabilities for policies to separate and really have the security guys focusing on their policy, their job, protecting the environments of the different traffics. So being able to see them and apply the right policy to that, while not slowing down the devs, because the policy will auto-adapt to the different changes, being the firewall as the load balancer and the other things. Of course, here in the demo, we only use one for the sake of the demo. So you can have multiple Fortigates and auto-scalable ones, all with the same principles of having the policy separated and the Fortigate automatically adapting to the moving, changing environments. That is a Kubernetes-driven one. Going even further, you usually have environments where you have the management part deployed in and managed by a Kubernetes environment, and you manage and deploy other applications and sometimes even different Kubernetes environments, or at least different namespace. So you have a lot of different aspects to take into account, but we can adapt to those different environments and being able to go for the different recommendations. The different parts you've seen are not only customer-centric, they are part of the recommendations CNCF and different and Azure put together. So to be able to protect the API servers, the different connections, the image, etc. We see that within the network with recognized security solutions by Fortinet, you can actually protect your private environments and keep the fast moving, adapting automation that you need when you move to Kubernetes. Thanks for listening, and I hope you enjoy it and try the demo by yourself, because it's available somewhere on GitHub for you to play with. Enjoy!